Ayan, magandang araw sa inyong lahat. Ako po si Hernan Benitez at ito po ay ang ating lecture video on the introduction or our introduction to interrupts for microcontrollers. So, coverage of this video and lecture slides are on first defining an interrupt, which I think you should be familiar with, especially with the first parts of EEE153. And then we will be defining these two acronyms, IRQs and ISRs, and then interrupt vectors. And then lastly, we will talk about interrupt priorities, interrupt testing, and interrupt masking. So hopefully by the end of this video lecture, may magandang idea na kayo about these. And so first, interrupts. So you should be familiar. So for example, meron kang ginagawa, kasi may biglang tatawag sa'yo, "Hoy, yung sinasampay niyo, umulan." So, parang na-interrupt ka. You have to break from your normal program flow in order to attend to a certain event. So, an interrupt, to put it more formally, is a notification of a certain event occurring. So, to put in even more formal terms, it's a forced deviation from normal program flow by external or internal event. So yung real-world analogies natin dito, kumari, nag-aaral ka, you're on your laptop or your tablet or your phone or whichever device, and you receive a phone call. So, unfortunately, kailangan mo tumigil mag-aral para sagutin yung phone call na yun. So yung normal program flow natin is yung pag-aaral, and yung external event or yung ating interrupt is yung receiving a phone call. So another example din dito, sa TV, if may cable pa kayo. So if you're, kung ano nanonood ka ng teleserye or whatever, and then poof, biglang may diditaw, breaking news. We interrupt this program for some breaking news, for example. So, ang normal program flow, yung normal na pinapanood mo, tapos yun, may interrupt tayo from breaking news. And then, lastly, yung yung normal program flow natin, sarap-sarap matulog, sarap-sarap biga, so biglang morning alarm. So, kailangan mo gumising. And then, so technically, yung buong umaga, or actually yung buong time na gising ka, is you servicing the interrupt, tapos yung normal program flow is yung tulog ka. Anyway, to put it in a more specific context sa microcontroller. So for example, meron tayong main program over here. So mag-execute lang yung program natin normally. So let's assume na pag naging white, tina-execute natin yung current line na yun. And then somewhere here, may darating na interrupt request or what we call IRQ. So IRQ kasi interrupt request. Sige, parang so anong gagawin ng ating program pag may dumating na interrupt request? So in order for us, so yun, pag may interrupt, we deviate from the normal program execution. So magkakaroon ng context save. So itong context save ay yung ginagawa natin whenever we have a subroutine or a function that will be called by a program. So dito ka nagsisave ng values sa stack. Yung current values ng register mo, isisave mo muna sa stack before ka pumasok sa isang subroutine. So servicing or yung addressing an interrupt is actually is technically calling another subroutine called the interrupt service routine. So, ayan, so yung deviation from normal program flow is this ISR, and then yung normal program flow. So after ma-save ng context, as with any subroutine or any function, kailangan mo i-save mo na yung context para alam mo saan ka babalik. tsaka pa lang mag-start i-service yung interrupt. And then mag-run yung ISR, like function, like subroutine. Yung pagkatapos niya is context store. So yun yung i-reload mo yung values ng yung mga registers. And then, yun na yan. And then, excuse me. And then babalik tayo sa main program. And so parang walang nangyari. Although, technically may nangyari, yung gagawin dapat yung ISR mo. Pero in the eyes of your main program, tuloy-tuloy lang siya. So, parang let's i-dissect lang natin siguro yung scenario na to. So, an interrupt request, so paano siya physically makikita? Or paano mo siya actually makikita sa iyong microcontroller? So, first and foremost, an interrupt request should come from an interrupt source. So, if you look at your datasheet, nakikita mo yung mga interrupt source says na kayang i-address or kayang i-notice ng ating microcontroller. So every microcontroller is different. So you should always have to check your datasheet in order to find out which of the interrupt sources are available. Pero ang usual na meron dyan, mga timer interrupts, software interrupts, pwede rin. And then external interrupts. So meron kang external pin na pag inactivate ng ating input dun sa pin na yun, magkakaroon ng interrupt internally. And then yung mga change notification, which I will make a separate video on, timer, and then comparator, ADC conversion, the time clock alarm, so meron pang actual na alarm clock, si quick 32mm. And so meron pang mga SPI, UART, so yan yung mga communication protocols which we will discuss in a later video. So ito medyo shortened version siya, pero if makikita niyo yung buong table sa datasheet is meron pa siyang mga columns dito. So meron tayong related na interrupt bits or actually yung mga special function registers, yung mga IFS0, IPC0, IPC0 to 3, mga SFR yan, tapos naka-specify kung anong bits yung naka-assign sa particular na interrupt source. So obviously, ayun nga, available sources will be different between microcontroller families and even yung mga family members or yung mga same family, meron silang mga konting differences. So let's first notice yung column dito, which is the interrupt flag and interrupt enable bits. So obviously, pag sinabi natin flag, so somehow related siya when nag-activate or nagkakaroon ng interrupt yung or nagiging or present ng certain interrupt, so yung flag na should be there. And of course, hindi naman natin usually kailangan lahat ng interrupts. So meron lang tayong siniset as enabled. So, and we can see here yung parang generic interrupt structure. So this is from yung isa nating reference. So makikita natin dito yung interrupt natin, yung interrupt source natin. Technically, ang kailangan mo lang gawin is assert a line or set a certain input to 1. Although internally, pwede mo namang iset na maging 0, pero usually, you assert it to 1 kasi meron tayong SR register dito na syempre pag nag-1 si set, magwa-1 yung output. So pag nag-occur yung interrupt, kahit na bumaba siya eventually, nangyari pa rin siya. So kailangan mo pa rin siyang i-address. So kaya nagkakaroon tayo ng interrupt flag na dinadrive ng isang register. So, yung interrupt flag natin will read 1 if the interrupt has occurred. So it doesn't have to be still occurring, it just has to occur. So any difference on? So for example, meron kang kung external interrupt siya, kung push button, pag gusto mo interrupt pag nag-high, Pero pag tumigil na yung pagka-press, pero hindi mo pa siya na-address, ano pa rin interrupt mo? So parang it just needs to happen. It does not need to still be happening. So for the interrupt enable naman, so basically i-end gate mo yung enable at saka yung flag. And that, so pag pareho silang 1, yun lang yung case na mababato yung interrupt mo papunta sa CPU over here. So itong other maskable interrupts, we'll discuss this later. And then for here, for this particular interrupt structure, meron tayong global interrupt enable. So usually, during your initial setup, gusto mong i-disable mo na lahat ng interrupts para tuloy-tuloy muna yung configuration. Pag tapos na lahat ng configuration, doon mo lang i-enable lahat ng interrupts para mas organized siya basically. And of course, ayaw mo naman nagkakaroon ng interruptions pagka nagko-configure ka pa lang kasi you're not expecting your peripherals to function properly at that point. So, in a single slide, para i-characterize or para ma-realize ang isang interrupt request event, the interrupt source needs to send a signal to your interrupt controller basically. And then once that happens, the interrupt flag must be asserted or set to 1. So usually may hinihintay lang tayong clock signal para mag-1 siya. And then lastly, the interrupt enable SFR needs to be set to 1 before the interrupt flag is actually, or the IRQ actually reaches the CPU. So, okay, may idea na tayo kung ano yung IRQ. What if dalawang interrupt request yung dumating at the same time? So, doon dumadating si interrupt priority. So, going back dun sa table kanina, yung last 2 columns dito is for priority and sub-priority. So, ang interrupt priority, as the name suggests, pag higher priority ka, ikaw yung mas importante and ikaw yung uunahin service ng microcontroller. So, total priority levels differ. For the PIC32mm, meron tayo interrupt priority 1 to interrupt priority 7. Now, meron tayong special term. Kung may dalawang interrupt na nag-occur, isa lang yung pinili natin dahil siya yung sa taas na priority. So, lahat ng ibang interrupts na nag-occur kasabay niya, we call them masked. So, for example, meron kang 5 interrupt na nag-occur sabay-sabay. So, syempre, isa lang yung masa-service mo doon. So, unless multi-core na. Pero, hindi lang, parang hindi ako familiar sa multi-core. So, usually, isa lang yung kaya nating service. So, all the other interrupts na nag-occur, we call them masked interrupts. So, nandun pa rin sila usually. And hindi pa natin sila sa service. So, usually sa service natin sila later on. And then, some interrupts are non-maskable, so IP8 and above. So usually, we usually don't care na doon sa actual na interrupt priority. We just know na si CPU na bahala when it comes to these non-maskable interrupts. So, ayun, so may classifications actually sila. So usually, meron tayong exceptions, which is yung usually pagka software related siya, for example, nag-divide by 0 inside the program execution, meron tayong divide by 0 exception. So meron sariling parang may hindi naman na siya ISR, exception handler na usually ang tawag para i-address yun. Next is yung traps, which is more on pagka basically may na-miss ka in memory, mali yung pagkakabasa mo ng memory, and then sa faults is yung pag merong hardware problem inside, or parang the microcontroller is expecting this thing to be occurring pero it's not occurring, so nagkaka-fault. And then yung abort is pagka wala na, finish na, abort. Or for example, nawala ng power, yung clock biglang tumigil or parang ito na yung mga worst case scenarios. So, hindi naman na kailangan natin i-identify yung mga to. We just need to know they exist. And nasa leadership naman sila na. And so, non-maskable. So, as you may notice, yung mga examples natin, ito yung mga kailangan i-address agad. So, needs to be serviced as soon as they happen, regardless of what else is happening doon sa ating microcontroller. And then, ayun, program execution may or may not resume properly. So for exceptions and traps, usually, kaya pong mag-recover. Pero pag faults and aborts, usually hindi na kailangan. Baka kailangan na mag-reset or mag-replace ng actual parts actually. So, ayun, paano ito nagagawa in our structure or parang ating block diagram. So, dito, di ba, mayroon tayong OR gate. So essentially, lahat ng nandito, mga same priority sila. Or you can make a specialized na OR gate or pwede kang gumawa ng decoder para makapag-distinguish siya ng priority. And if hindi nyo naman pansin ito kanina, meron tayong direct line from non-maskable interrupts. Diretso sila sa CPU. So hindi na sila dumadaan sa ganitong sort of stuff para agad silang ma-notice and ma-address. Then, going back, if meron tayong dalawang interrupts, IP5, IP4, so syempre unahin natin si IP5. So IP4 will be masked. So parang naka-standby lang siya dyan. And then, ayun, service natin si timer. And then usually inside the timer ISR, meron tayong yung timer interrupt flag natin. We usually clear it dito sa program natin. So, kung babalikan natin yung structure natin kanina, yung reset ng interrupt flag is either by the CPU or our program. And usually in my experience, or yung sa mga na-handle ko na ng mga microcontrollers, the safest option is always to clear the flag yourself. So, kahit hindi mo na siya hanapin sa datasheet, wala namang masama pagka sinet mo siya to 0. So, parang medyo good practice na rin siyang ginagawa kahit na alam mo i-reset siya. And then babalik siya sa main program after ng ISR. So essentially, tapos na si timer interrupt, na service na siya, balik na sa main program. And pagkabalik sa main program, one of two things can happen for the masked interrupts. So yung more likely and yung mas aware ako nung nangyayari din sa mga encounter ko ng microcontrollers is that the interrupt flag will be unchanged. Since si CPU, madalang lang siya makialam sa mga interrupt flags. So, since unchanged si interrupt flag, high pa rin si interrupt flag, high pa rin yung enable, mapapadala pa rin sa CPU yung signal. So, essentially, parang ngayon lang dumating si IP4 na interrupt. So kaya din sila parang masked. So parang tinakpan lang natin sila. And pagkatapos ma-service ng higher priority interrupt, parang matatanggal yung mask nila and andyan ka pala. Sasabihin ng CPU. And siya naman yung isa-service na. So depende rin kung mag-execute pa siya ng one more line. Pero usually, it doesn't really matter for us kung kailan siya mag-start. Pero yun. Ang other option naman, so yung first scenario is walang mangyayari kay interrupt flag. And then parang manonotice na lang ng CPU na meron pa pala isa pang interrupt na hindi niya pala service. Yung less likely pero possible, lalo na sa mga low resource na microcontrollers, automatically mag-clear yung lahat ng interrupt flags ng ISR. So parang nag-reset lahat ng interrupts in that case. Although yun nga, it's less likely but still possible. So always double check your datasheet. So assuming yung first scenario, wala mangyari sa interrupt flag. So basically parang ngayon lang dumating yung ADC conversion interrupt. So ayun, service mo si ADC ISR and then balik ka na sa main program mo. Dali lang naman, di ba? So yung next scenario natin, what if pareho sila ng interrupt priority? Pareho sila ng IP5. Hindi, wala na lang. So we can't actually distinguish which came first kasi yun nga, may clock tayong sinusundan. So if within the clock period, biglang pareho silang dumating, we can't really say kung sino nauna. So kasi usually, syempre sa service mo kung sino nauna. Kung same priority lang naman sila. Pero in this case, at the same time mo sila manonotice, ano ang pwede gawin ng microcontroller? So, ayan. Yung first, yung medyo madaya, pero ginagawa talaga is some microcontrollers only allow one source per priority. So, pag meron ng priority level 7, wala nang iba pang priority level 7. So, technically, hindi magkakatay. Dali, di ba? Although, yung usual, or sa mga higher level na mga microcontrollers, meron tayong natawag na sub-priorities. So, that is yung last column over here ng ating interrupt table. So, ayun, what if dagdagan na lang natin yung bits ng priority but kailangan itong mag-sub-priority? So, first, usually kasi, lalo na within the same manufacturer, parang medyo set na yung mga number of interrupt priorities. So, yung IP7 is actually medyo sa microchip yun yung parati ko nakikita. So, siguro it's a way na parang standard yung interrupt priority numbers nila across devices. Although, meron din siyang other implications which we will be covering later on. So, parang abangan. Pero, ayun. And so, if pareho kayo ng priority, kung sino mo sa taas sa priority, siya yung masusunod. Now, if pareho pa rin, pareho yung priority, pareho yung sub-priority, ang gagawin natin is kung sino yung unang na-define doon sa table. Or usually, meron nakalagay na vector number or IRQ number sa mga interrupt tables natin. So, for the PIC32mm sa table natin, vector number yung nakalagay. So in this case, if dumating si core timer interrupt at saka si external interrupt ng sabay, since nauna si core timer dito, siya yung una nating service. So, kahit na in actuality, nauna yung external, pero yung pagbasa ng ating CPU, sabay silang dumating, una service si core timer interrupt. So, balik tayo dun sa initial na scenario natin. Dagdagan ko lang ng sub-priority. So, si ADC ngayon, sub-priority 3, and then si timer is sub-priority 1, para sila IP5. So, mamamask si timer interrupt. So, yun. So, yun ay pagsabay yung mga ating interrupt. So, what if sunod-sunod, hindi sabay-sabay? So, habang sinuservice mo si timer ISR, tsaka dumating si ADC interrupt. So, ano nang gagawin natin? So, ang mangyayari usually is interrupt nesting or also known as chaining. So, interrupting an interrupt. Wow. So, if alam mo yung mga Russian nesting dolls, di ba? It's a doll within a doll within a doll. So, yun din yung interrupt nesting. Kaya siya nesting. Kasi interrupting an interrupt, na pwede mo pang i-interrupt, kaya pang interrupt again. Kaya important yung context saving para matrack natin yung pag-interrupt ng mga interrupts. So, ayan. So, paano nangyayari sa interrupt nesting? Well, first and foremost, hindi lahat ng microcontrollers kayang gawin yung interrupt nesting. Pero usually, sa mga modern na microcontrollers, they are handled. Pero yan, lalo na kung low resource yung microcontroller mo, it might not be possible. So if it's possible, usually ang standard is, ang pwede na mag-interrupt ng current na interrupt is a higher priority interrupt. So pag same kayo ng priority, tatapusin nyo muna yung current ng ginagawa before siya ma-interrupt. So, same priority interrupts will be masked. Kahit na mas mataas yung sub-priority mo, usually, hindi niya ma-interrupt yung currently na run. So, going back to our example, IP5 yung timer ISR. And then IP4 lang si ADC interrupt. So, si ADC interrupt is actually mamamask. So, ayun, pag na-mask, essentially, parang hindi siya dumating. So, parang tinakpan o tinago muna siya. Set aside muna, tapusin muna si timer ISR. Now, in this next scenario, pareho sila IP5, pero sa priority 1 si timer, sa priority 2 si ADC interrupt. So, it's still not a higher priority kasi same priority sila at 5. At kahit mas mataas yung sub-priority ni ADC, hindi siya ma-service or ma-mask pa rin siya. Pero, note na if sabay si ADC at si timer dito, si ADC muna yung sa service niya. So, doon nagkakaroon ng difference or nagkakaroon ng effect yung sub-priority. Now, pag si timer ay IP5, si ADC ay IP6, yun pa lang yung time na kayang interrupt ni ADC interrupt si timer ISR. So, high priority siya, so we service it. So, in between the execution ng timer ISR, magkakaroon ng ADC ISR. So, ayun. Hopefully wala pa kayong questions for now kasi recorded lang ito. So, going back to our parang big picture. So, na-dissect na natin ano yung mga pwedeng mangyari sa IRQ. Kung kailan siya pwedeng mauna, sino kailan pwedeng dumating, etc. etc. So, move on tayo dito. Si interrupt service routine, paano natin siya nilalagay sa microcontroller? So, how do we actually program it? So, as with any part of your code sa microcontroller, sinistore natin siya in memory. And then, the ISR, being a medyo special siya, di ba? It's for interrupts. Meron tayong special section in memory for the ISR. So, paano natin malalaman kung saan doon sa special part of memory yung specific ISR for a specific interrupt? So, dito dumadating yung tinatawag ng interrupt vectors. So, as you may have noticed kanina sa table, so balik natin sa meron tayong tinatawag na vector number or yung actually vector name per interrupt natin. So each of these vector numbers correspond to a location ng ating ISR. So in some microcontrollers or in usual modern microcontrollers, meron tayong multiple interrupt vectors. Pero meron tayong ibang microcontrollers, lalo na yung low resource, isa lang yung interrupt vector nila. So you always have to check the location. And then, ayun, ang requirement naman natin, each interrupt source kailangan merong assigned na vector. Pero ang isang vector can be assigned to multiple sources. Lalo na kung pare-pareho lang naman sila ng parang ginagawa or pareho-pareho sila ng ina-address. So for example here, sa PIC32MM, actually alam ko walang nag-share. But for the PIC32MX series, may kita mo dito, meron tayong tatlong interrupts for SPI, pero ang vector number nila lahat 23. So in this case, iba yung IRQ number sa vector number. Pero dito sa PIC32MM, I'm assuming na since vector number lang yung nakalagay, same din siya with the IRQ number. So there are cases na kailangan mag-share ng vector number. So, paano yun? What if yung mga interrupts ko, wala ito, yung isa receive, yung isa transfer? So, paano ko ma-differentiate sila? Or paano kung iba yung kailangan kong gawin for both at isa lang yung function ko? So, ayan, how will you service multiple sources in the same ISR? Siyempre, yung programmer yung mag-adjust. So, in your single ISR definition, gagawa ka lang, ito yung usual, gagawa ka lang ng if-else block. So, pag timer interrupt, interrupt flag yung enabled, timer ISR yung gagawin mo. Pag ADC interrupt flag yung enabled, ADC ISR yung gagawin mo. Pag external, yung external ISR yung gagawin mo. So, basically, if else block, pwede yung switch case. Pero basically, kailangan mo lang gumawa ng branching dun sa loob ng iyong ISR. So, okay na tayo sa IRQ, okay na tayo sa ISR. Itong context save and restore, context switching. So, ginagawa naman na yan ng computer before pa. So, alam niya na yan. So, siya na bahala dyan. Pero of course, that is yung usual. So, you can never be wrong if you check the data sheet. So, yeah. In summary, interrupts are asynchronous events that prompt the microcontroller to do a specific set of commands, which we call the ISR. And then before proceeding, we do a specific set of commands called the ISR before proceeding with the normal program execution. So parang, you can think of it as a function call na kayang dumating anytime. So dumadaan yung program mong ganyan, dadating yung interrupt, so parang magko-call ka lang ng function and gagawin mo na yung function bago mo ituloy yung isa. So parang may masisingit na function call dun sa program execution mo. Then next is interrupts are given a priority to determine which to service first or if an interrupt can interrupt the current ISR. So may tinatawag na interrupt priority, nasa taas yung priority, mauuna siyang is-service. Pag mas taas yung priority mo sa sinaservice na interrupt, kaya mong interrupt yung interrupt na yun. And then lastly, yung ISR code natin, as with any other part of our program, kailangan natin siyang i-store sa memory. And then yung memory location naman na yun is determined by the interrupt vector na kayang i-share ng multiple IRQs. So, nakita naman na natin paano i-handle yun. So, yun lang naman for this video lecture. Hope you learned anything. For any questions, send me an email, post sa forums, and utilize all your communication channels in case of questions. So, magandang araw. Muli, hanggang sa susunod.